So friend, let's start for the discussion of circle. Circle is a very important chapter for your competitive exams as well as your board exams also. So first of all, we'll learn about the definition of circle. So what is definition of circle? So definition. We all know circle is the locus of a variable point whose distance from a fixed point is always constant. Is not it? So what is circle? Circle is the locus of a variable point. So if we assume variable point is P whose coordinate is x comma y, as we know in the study of coordinate geometry, the variable point indicates by x comma y. So locus of a variable point P x comma y whose distance from a fixed point so say the fixed point is suppose O. So fixed point is O and consider the coordinate is alpha comma beta. Okay, is always constant. Okay, so a circle is the locus of a variable point x comma y whose distance from a fixed point alpha comma beta is always constant. Okay, let the constant distance is r. Now let's look. So suppose this is the circle. So this is the fixed point O, which is alpha comma beta. Okay, and declare a variable point P x comma y. If P moves on this circle, then the distance of P from this fixed point O is always to be constant, which is r according to the definition. Is not it? And this fixed point O is known as the center of the circle and the fixed distance r is known as radius of the circle. So the fixed point alpha comma beta is the center of the circle, and the fixed distance r is known as what? The radius of the circle is known as radius of the circle. Okay, so we get the basic definition of the circle and we already learned about the center and the radius of the circle. Now let us develop the equation of the circle. Okay, so what is equation of the circle? Let's see. Equation of circle. Okay, as we discuss that circle is the locus of a variable point x comma y whose distance from a fixed point alpha comma beta is always constant, which is r. So any relation satisfying the definition of the circle with x, y and known constant will be the equation of the circle. So how we can develop the equation? Applying the distance formula, that is OP is equal to what? Clearly OP is equal to what? R. Definitely. So OP is equal to R. Now applying the distance formula, OP means what? The distance between x, y and alpha beta. So applying the distance formula, root over x minus alpha whole square plus y minus beta whole square is equal to R. Okay. So if we make whole square both side, we'll get x minus alpha whole square plus y minus beta whole square is equal to r square. So this is the equation of circle, because as it is related with x, y and alpha, beta, r are known constant, x, y are variable, and this equation satisfies the definition of the circle. So this equation must be represents the equation of the circle. So equation of circle whose center is at alpha comma beta and radius is r can be represented as x minus alpha whole square plus y minus beta whole square is equal to r square. So writing here equation of the circle whose center is at alpha comma beta, okay, and radius is r, and radius is r. This is what x minus alpha whole square plus y minus beta whole square is equal to r square. Clear? Now we are discussing the equation of circle in general form. Okay, let's see. So general equation of circle. The equation x square plus y square plus 2gx plus 2fy plus c is equal to 0 represents the general equation of circle. So write general equation of circle. Okay. So writing the equation x square plus y square plus 2 into g into x plus 2 into f into y plus of c is equal to 0 always represents a circle. So always represents a circle. Okay. Now, what are g and f? Here, the center of the circle is at minus g comma minus f and radius is square root of g square plus f square minus c. So, center of this circle is at minus g comma minus f and radius is equal to square root of g square plus f square minus of c. Okay, clear? If g square plus f square minus c is equal to 0, then the circle will be considered as a point circle. If g square plus f square minus c is greater than 0, then the circle is considered as real circle. And if g square plus f square minus c is less than 0, then radius will be imaginary. Then the circle is known as imaginary circle. So write down, if g square plus f square minus c is greater than 0 means the radius has a real value. So in that case, the circle is real. Okay. If g square plus f square minus c is equal to 0, in that time the radius becomes 0. So when radius becomes 0, then the circle represents a point. So circle is point circle. Point circle. Okay. And if g square plus f square minus c is less than 0, then the radius become what? Imaginary, because the negative sign will come under the square root. Is it? So in that case, the circle is known as imaginary circle. So when g square plus f square minus c is less than 0, then it is imaginary circle. Okay. Now, our task, how to prove the equation x square plus y square plus 2gs plus 2fy plus c is equal to 0 represents a circle. Okay, so let's have a proof. So friend, we are going to prove that the general equation of the circle is of the form of x square plus y square plus 2gx plus 2fy plus c is equal to 0. Okay, and its center is at minus g comma minus f and radius is root over g square plus f square minus c. Look how to prove. We all know equation of the circle whose center is at alpha comma beta and radius is r can be written as x minus alpha whole square plus y minus beta whole square is equal to r square. From here, we will start our discussion. So, we know equation of circle whose center is at alpha comma beta and radius is r and radius is r can be written as what? X minus alpha whole square plus y minus beta whole square is equal to r square. We already proved it, is it? Just in the previous discussion. Now, if we open it, that is, if we expand x minus alpha whole square in the form of a minus b whole square, and if we expand y minus beta whole square in the form of a minus b whole square, then what we will get? We get x square plus y square minus 2 alpha into x minus 2 beta into y plus alpha square plus beta square minus r square is equal to 0. Is it? So, we can write this equation as x square plus y square plus 2 into g into x plus 2 into f into y plus of c is equal to 0. C is a constant and alpha squared plus beta square minus r square is equal to r square is also a constant. Okay. So, what are g, f and c? So, here g is basically equal to minus alpha, f is equal to minus beta and c is equal to alpha square plus beta square minus of r square. Is it? So, what are the value of alpha and beta? So, we can say center is at alpha comma beta. So, what is the value of alpha? As g is equal to minus alpha, so we can say alpha is minus g. And as f is minus beta, so we can say beta is equal to minus f. So, we are writing minus f. So, center is at alpha comma beta, which is basically equal to minus g comma minus of f. Okay. And also finding the radius. Also, we see c is equal to alpha square plus beta square minus r square. From here we get the radius. So, c is equal to alpha square plus beta square minus of r square. So, make side change. We can write r square is equal to alpha square plus beta square minus of c. Okay. So, what is alpha square plus beta square? As alpha is equal to minus g and beta is equal to minus f. So, alpha square plus beta square can be written as g square plus of f square. So, we can write r square is equal to g square plus of f square minus of c. Okay. Now, what is r? R is square root of g square plus f square minus of c. So, r is equal to square root of g square plus f square minus of c. Is it clear to you? So, what we learned? We learned x square plus y square plus 2gx plus 2fy plus of c is equal to 0 always represents equation of a circle, and this is known as the general equation of the circle. The center of this circle is minus g comma minus f and the radius is square root of g square plus f square minus of c. Okay. Now, come to another form of the equation of the circle is known as the diameter form of the equation of the circle. Okay. Let's see. So, we are discussing the equation of circle in the diameter form. Okay. So, heading is equation of circle in diameter form. Okay. So, what types of equation it is? the equation of circle whose any dia has ends given as x1 y1 and x2 y2 can be written as x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. That is, here the extremities of the diameter are given. Okay, so right please. If x1 comma y1 and x2 comma y2 are the ends means the extremities, are the ends of any dia. Dia means diameter. So if x1 y1 and x2 y2 are the coordinate of the points of the ends of any dia of a circle, then the equation of the circle can be written as, then the equation of the circle can be written as what? X minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. So written as x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Okay, so this is the equation of the circle whose any dia has ends x1 y1 and x2 y2. Got it? So what is the center of this circle? So center of this circle is, center is at just the midpoint of the ends of dia. So this become x1 plus of x2 divided by 2 comma y1 plus of y2 divided by 2. Okay, and what will be the radius? Just the half of the length of the diameter. So radius is half of the length of the diameter. That means, what is the length of the diameter? The distance between the ends of the diameter. So you can apply the distance formula, that is x1 minus x2 whole square plus y1 minus y2 whole square. Is it? So now we have to prove this, how this equation of circle can come. Okay, so let's have a look. So student, we are going to prove that equation of circle whose any dia has ends x1 y1 and x2 y2 can be written in the form of x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Okay, so going to prove this, and to prove this we will first draw a circle. So let's draw a circle. So this is a circle whose any dia has ends, let's x1 y1 and x2 y2. So this is any dia and ends of this dia are given as x1 y1 and x2 y2. Consider just this point is A and this point is B, that is AB is the dia. This is the center, suppose O. Okay, now we have an alternative definition of the circle, that if we declare a variable point P on this circle, then P produce an angle with AB, that is angle APB will be always become what? 90 degree, is not it? So this angle is always 90 degree. Clear? Now we have to establish a relation related with x, y and the known constant x1, y1, x2, y2 such that the conditions of the circle, that is P lies on this circle, this satisfied. Now what is the condition? The condition is that the angle APB is 90 degree. Okay, so maintaining these conditions, we will find the equation of the circle. So it is clear to us, as APB is 90 degree, so obviously AP is perpendicular to BP, is it? So slope of AP and slope of PB, if m of PA and m of PB, then their product will be -1. Okay, so we can write product of the slopes AP and BP, that is m of AP into m of BP should be is equal to what? -1. Okay. Now what is m of AP? The m of AP is, that is the slope of the line AP is what? Y minus y1 divided by x minus x1. So we are writing here y minus y1 divided by x minus x1, which is the slope of the line AP, and the slope of the line BP is what? Y minus y2 divided by x minus x2. So we are writing y minus y2 divided by x minus x2 is equal to minus of 1. So this is the relation between x and y and the known constant x1 y1 and x2 y2, and this relation established by the property that the angle APB is what? 90 degree, and where P is nothing but a variable point, is not it? So this equation must be represents the equation of a circle in the diameter form. So arranging it, and we'll write it is in the form of x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Okay, so writing it, y minus y1 into y minus y2 is equal to, making the cross multiplication, so minus of x minus x1 into x minus of x2. Okay, so shift this in the left hand side, we'll get what? X minus x1 into x minus of x2 plus y minus of y1 into y minus of y2 is equal to 0. Okay, very easy. So in this way we can find the equation of the circle in diameter form. Okay, please remember this result. Now what is the center of this circle? Obviously center of this circle is just the midpoint of AB, and the center is obviously what? The midpoint formula, applying the midpoint formula of AB, that is x1 y1 and x2 y2. So the midpoint O, which is the center, is nothing but x1 plus of x2 divided by 2 comma y1 plus of y2 divided by 2. Okay, and what is the radius? Radius is just the half of the diameter. And what is the diameter? If we apply the distance formula between A and B, we will get half of square root of x1 minus of x2 whole square plus of y1 minus of y2 whole square. Okay, so clear it is. Now we are coming the another concept on the circle, that is the length of the tangent drawn from an external point to the circle. Okay, so let's have a look. So friend, now we are discussing the point that how to find the length of a tangent to a circle drawn from an external point. Okay, so the heading is length of a tangent drawn from an external point. Okay, so let the equation of the circle is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0, and let an external point x1 comma y1 of the circle, then the length of the tangent drawn from the point x1 y1 to the circle x squared plus y squared plus 2gx plus 2fy plus c is equal to 0 can be written as square root of x1 square plus y1 square plus 2g1x plus 2f1y plus of c is equal to 0. Okay, so writing this statement, length of tangent to the circle x square plus y square plus 2zx plus 2fy plus of c is equal to 0, drawn from an external point. External point means the point lies outside the circle. So external point P, that is x1 comma y1, is equal to, what is the result? Square root of x1 square plus y1 square plus 2zx1 plus 2fy1 plus of c. Look, the expression inside the square root is a constant, as all x1, y1, g, f and c are constant. Okay, so it is easy to remember that just you substitute x and y by x1, y1 and make the square root, will get the length of the tangent. Okay, so if we give the name L, so L is equal to this. Now look how to prove it. Okay, so we are going to prove, and for this just we'll draw a circle first. So drawing a circle, so this is a circle and a point lies outside of this circle. Let the point is P, whose coordinate is x1 comma y1. Okay, and what is the equation of this circle? The equation of this circle is x square plus y square plus 2zx plus 2fy plus of c is equal to 0. Okay, so obviously draw a tangent from this point to this circle. Let the point of contact is Q. Okay, so the length PQ is known as length of the tangent. So length PQ is what? It is the length of the tangent. Length of the tangent. So what do we want to find? We want to find the value of PQ. Okay, so to do this, first of all, trace the center. Say the center is at O, and what is the coordinate of the point O? As the equation of the circle is x square plus y square plus 2zx plus 2fy plus c is equal to 0, so its center will be minus g comma minus f. So we are writing the center is at minus g comma minus f. Okay, now complete the triangle joining OQ and joining OP. So obviously it is a right angle triangle and right angle at Q. The OP is the hypotenuse. You can consider PQ is the base and OQ is the perpendicular. Okay. Now what is the length of the perpendicular drawn from O to Q? It is just simply the radius of the circle. So what is the radius of the circle? If it is R, we know from this equation R is nothing but square root of G square plus F square minus of C. Is it? And what is OP? OP is just the distance between P and O. That is, we can apply the distance formula between x1, y1 and minus g minus f. We can get OP. Now from this right angle triangle, what we can say? From triangle OPQ, we can say, applying the Pythagoras theorem, what we can say? OP square is equal to PQ square plus of OQ square. Is it? So what is PQ square? PQ square can be written as just OP square minus of OQ square. And this PQ is the length of the tangent which we write here. Okay, so let's calculate the value of PQ. So PQ square is equal to OP square. OP square means the distance between x1, y1 and minus g minus f. So applying the distance formula, x1 plus of g whole square plus y1 plus of f whole square. No need to write the square root as we have here OP square. So square root will be vanish. Minus OQ square. What is OQ square? OQ square is nothing but R square. Is it? So we are writing this is as R square. So minus of R square. Clear? So let's simplify it. So PQ square can be written as x1 square plus y1 square plus 2zx1 plus 2fy1 plus g square plus f square, and R square means as R is equal to square root of g square plus f square minus c. So R square can be written as g square plus f square minus of c. So we are writing minus of g square plus f square minus of c here. Okay. So what is the value of PQ? From here we can easily cancel g square f square, g square f square, and minus minus plus c will become. So the PQ will be square root of x1 square plus y1 square plus 2zx1 plus 2f into y1 plus of c. Okay, so we already proved that the length of the tangent drawn from an external point x1 y1 to the circle x square plus y square plus 2zx plus 2fy plus of c can be written as PQ is equal to square root of x1 square plus y1 square plus 2zx1 plus 2fy1 plus of c. And to remember this, just we'll substitute x and y by x1, y1 in the given equation of the circle and we'll make the square root. Okay. Sometimes this can also be written as PQ is equal to square root of S1. What is S? S is just the left hand expression of the equation of the circle, that is s square plus y square plus 2zx plus 2fy plus of c. So S1 means in the expression of S, that is in the expression of x square plus y square plus 2zx plus 2fy plus of c, just you substitute x by x1 and y by y1. Then this will represent S1. S2 means just you substitute x and y by x2 and y2. We'll get S2. Okay. So remember this form of tricks also. So what is the length of the tangent? We can say for any circle S is equal to 0, the length of tangent is root over of S1, where S1 is the form of S when we substitute x by x1 and y by y1. Understand? Clear it is? Now come to the next discussion, that is the orthogonal intersections of two circles. Okay. So let's have a look. So discussing orthogonal intersections between two circles. So write down the heading orthogonal intersection of two circles. Okay. So orthogonal intersections of two circles. So consider two circles, one is x square plus y square plus 2z1x plus 2f1y plus of c1 is equal to 0, and another circle, that is x square plus y square plus 2g2x plus 2f2y plus of c2 is equal to 0. So if these two circles cuts orthogonally to each other, then the conditions of orthogonal intersections become 2g1g2 plus 2f1f2 is equal to c1 plus of c2. Okay, and we will prove this also. So first of all, write the notes. If circles x square plus y square plus 2z1x plus 2f1y plus of c1 is equal to 0, and x square plus y square plus 2z2x plus 2f2y plus of c2 is equal to 0. These are two circles cuts orthogonally Okay, that is they cut orthogonally to each other. Then the conditions of orthogonal intersections become 2 G1 G2 plus 2 F1 F2 is equal to C1 plus of C2. This is very important logic, or this is very important conditions for numerical basically. So you must remember this, okay, and we will prove this. So let's start to prove. So look how we can prove this. To prove this, we will draw first two circles. So let us draw two circles. One circle is this, and let's draw another circle. So another circle is like this. So we draw two circles. Equation of this circle, assuming x square plus y square plus 2z1x plus 2f1y plus of c1 is equal to 0. Okay, and equation of this circle considering x square plus y square plus 2z2x plus 2f2y plus of c2 is equal to 0. So these are two circles. So first circle has center at minus g1 comma minus f1, and we can also find the length of the radius of this circle. Similarly, the second circle has center minus g2 comma minus f2, and its radius will be what? Root over g2 square plus f2 square minus of c2. Okay. Now these are 2 points of intersections of these circles. Is it? The character at this point of intersections will be same as the character of this point of intersection, because due to the symmetric nature of the circle. So we will discuss only this intersecting point. So first of all, let us draw the tangent at this point of intersection. So we draw a tangent. Okay, give the name of this point is suppose P. So this point of intersection is P. So draw another tangent to this circle. That is, first we draw this red color tangent to this black circle at the point of intersection P. Now we are drawing the green color tangent to this blue circle at the point of intersection. So look. So this is another tangent at this point of intersection. Look, I tried here to make these tangents perpendicular to each other. So this is perpendicular. This referred the angle of intersections is 90 degree. And when the angle of intersection is 90 degree, we say the circle cuts orthogonally. It is. So definitely, now one very interesting conditions occur. What? Suppose this is the center of this circle. That is, the center is 1 whose coordinate is minus g1 comma minus f1. And suppose this is the center of this circle. Give the name is O2, and coordinate of its will be minus g2 comma minus of f2. Okay? Clear? It is clear to us this green color tangent, that is tangent to this blue color circle, will be passing through the center O2. Why? Because this red color tangent is the tangent to this black color circle, and at the point of contact, this is perpendicular. So this must go through the center. By the same property, this tangent will go through the center of this second circle. Is not it? So if we complete this triangle PO2O1, this triangle PO2O1 will be the right angle triangle, is not it? Now applying the property. In triangle PO2O1, what we get? Definitely O1, O2 is nothing but the hypotenuse, and these are two perpendicular to each other sides. Okay, so we can say if this radius is R1 and if this radius is R2, then R1 square plus of R2 square is equal to O1, O2. It is clear that length of PO1 is nothing but R1 of the first circle, and length of PO2 is nothing but the R2, that is the radius of the second circle. What is the value of R1? We know R1 is nothing but root over G1 square plus of F1 square minus of C1. And what is the value of R2? We know R2 is nothing but root over G2 square plus F2 square minus of C2. Is it? So applying the Pythagoras theorem in the triangle PO2O1. So what we get? R1 square plus R2 square is equal to O1 O2 square. Now what is the value of R1 square? Already we write. R1 square is G1 square plus F1 square minus C1, because square root will be vanish. So write here G1 square plus F1 square minus of C1 as R1 square. Similarly, R2 square can be written as G2 square plus F2 square minus of C2. Okay, this is equal to O1 O2 square. Now how we get O1 O2 square? We will apply just the distance formula between the minus G1 minus F1 and minus G2 minus F2. So applying the distance formula, we will get G1 minus of G2 whole square plus F1 minus of F2 whole square. Okay, just we will vanish the square root, as square of O1 O2 square is at the right hand side. So if we simplify this, what we will get? Minus C1 minus C2 is equal to minus 2 G1 G2 minus 2 F1 F2, because G1 square, G2 square, F1 square, F2 square will be cancelled from both sides. So eliminating the negative sign from both sides, we get 2 G1 G2 plus 2 F1 F2 is equal to C1 plus of C2. Okay, so this is the condition which we prove for orthogonal intersections of two circles x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0, and another circle is x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. Clear?